Problem 10.6, calculate the derivative of the following functions. Okay, this is one of the corollaries from the fundamental theorem of calculus. So we have a function f like this. The derivative of f is going to be, so let's call f the integral between g1 of x and g2 of x of a function, let's call it h of x, right, dx. Now the derivative of f is going to be h evaluated at g2 times the derivative of g2 minus h evaluated at g1 times the derivative of g1. Okay, so let's apply this formula here. Now first, f of x is let me write it directly, right? F of x is the integral between x squared and x cubed of e to the t over t divided by t, right? So the derivative of f is going to be the derivative of x cubed, which is 3x squared, times e to the x cubed divided by x cubed, minus the derivative of x squared, which is x squared, 2x, sorry, e to the x squared divided by x squared, right? Now here this cancels out, so this is just 3e to the x squared minus 2e to the x squared, sorry, a cube x squared divided by x. Okay, let's do part 2. F is the primitive, the integral between minus x cubed and x cubed of 1 over 1 plus the sine squared, right? So the derivative is going to be 3x cubed divided by 1 plus the sine squared of x cubed, and then minus the derivative of this, which is plus 3x squared over 1 plus the sine squared of of minus x cubed, right? Now this is going to be the sine of minus x cubed times the sine of minus x cubed. The sine of minus x cubed is minus the sine of x cubed minus the sine of x cubed. So this is just going to be plus exactly like this. So this is just 6x squared 1 plus the sine squared of x cubed. Part 3. The integral between 3 and the integral between 1 and x of sine cube t of dt over 1 plus the sine 6t plus t squared. Okay, so f prime is going to be the derivative of this, okay, the derivative of this function is going to be the sine cube of x, right? So the derivative of the sine cube, then divided by 1 plus the sine to the 6 of, and then evaluated at the integral 1 to dx sine cube of t dt plus the integral squared, and then minus the derivative of 3, which is 0, so that's it. Okay, this is the derivative. Okay, part 4. F prime, let's see, f is going to be the integral between 2 and the exponential, okay, e to the integral between 1 and x squared of the tangent of the square root of t dt, right? Let's compute the derivative of this first. The derivative of this is e, the same thing, e to the integral, right, times the derivative of this, but the derivative of this is the derivative of this 2x times the tangent evaluated at this, so the tangent of x squared is the tangent of x, right? And then minus the derivative of 1, which is 0, so that's it. Okay, so now this is 2x, the tangent of x, times the exponential between 1 and x squared of the tangent of t divided by t divided by the logarithm of the exponent of the exponential. So this is just divided by the integral. the integral between 1 and t squared, and x squared, sorry, of the tangent of the square root of t dt. Okay, and then minus this, but this is constant, so that's it. Okay, let's do part 5. F of x is the integral between 0 and x of x squared ft dt, where f is continuous. Okay, let's see. F prime is going to be the derivative of x, which is 1 times x squared f at x, right? And then we have the derivative. Let's see. Wait a minute. So one way to do it, this is realize that this is just x squared times the integral, right? The value of x squared, so it's not it's a constant inside this integral, right? So the derivative of this, we have to apply the rule of the product. This is 2x 0, the integral, right, plus x squared times the derivative of this integral. So this is just f of x. Okay, and that's it. And then we have the last part is the sine of the integral between 0 and x of the sine of the integral between 0 and y of the sine cube of t dt. Okay, now the derivative of this is going to be the cosine of this, right? So it's the cosine of the integral between 0 and x of the sine of the integral between 0 and y of the sine cube of t dt dy, right? Now we have to compute the derivative of this because we are applying the chain rule. Now the derivative of this is the sine of this evaluated at x. So just the sine of the integral between 0 and x of the sine cube of t dt. That's it.